as x goes to negative infinity of 5x cubed minus 2x all over x squared plus 1. Now, where is your precious shortcut now? What did those shortcuts you learned in high school tell you about this limit? Can anyone tell me? What did they tell you about this limit?
I remember that if it's top heavy, it would go to infinity. So
Okay, all right. So Emily says if it's top heavy, it goes to infinity. All right, so we'll see if Emily is right. Okay, so what is the master strategy? The master strategy for computing these limits, as I wrote earlier, is what? Factor out the highest power of the numerator and denominator separately, right? That's what I wrote here for master strategy. Or you can factor out just the highest power of the denominator, but I'm going to stick with factoring out the highest power of numerator and denominator separately. Okay, so let's do that here. So the highest power of the numerator is x cubed, so factor out x cubed. Highest power of the denominator is x squared, factor out x squared. Okay. Sophia, so what Emily means by top heavy is that the degree of the numerator is higher than the degree of the denominator. That's what she means. So 3 versus 2 in this case. Okay, so if I factor out an x cubed from the numerator, I get 5 minus 2 over x squared. If I factor out the x squared from the denominator, I get 1 plus 1 over x squared, right? So far, all I've done is algebra. Now I'm going to use calculus. Right, so I'm going to look at the limit of each term separately. It's kind of like when we did those trig limits, right? You look at each term separately. Okay, x going to negative infinity of the first term times limit as x goes to negative infinity of the second term. Okay, so far I've done algebra and I've separated the limit into two separate limits, and I'm going to analyze them separately. So let's do the second limit first, because that's a little bit easier. What would you say about this second limit? How would you go about calculating that second limit? We can actually calculate it pretty much right now without any further modification. How would you argue? What property would you use? And this is, I'll give you a hint, this is what the first 15 minutes of class were all about. Okay, so Bryn says 5 minus 0 over 1 plus 0, right? So Bryn is using that special limit. Look at these reciprocals, right? I have 2 over x squared, a positive reciprocal power. 1 over x squared, a positive reciprocal power. So what happens to each of these terms? As x goes to negative infinity, these terms go to 0. Right? That was that special limit that we did at the very beginning of lecture. Right? That's why I did it, because our master strategy takes advantage of that, of those reciprocal powers. Okay, so that means on the next line, or I can write that this is going to be, I haven't done the first limit yet, but the second fraction is going to be 5 minus 0 over 1 plus 0. Okay, now let's look at the first limit. So first of all, I can cancel, right? X cubed over x squared is just x. Now, what would you say is that limit? Would be 1. Well, if x is going to negative infinity, what's happening to x? It's almost like a trick question, right? If x is going to negative infinity, what's happening to x? It's going to negative infinity. Right. Okay, so that means let's put this together. The first fraction has a limit of negative infinity, and the second fraction has a limit of 5 minus 0 over 1 plus 0. So I get here negative infinity times 5. Now, what would you say about that? Now, keep in mind, infinity is a special symbol, and you have to think about what this symbol means. The negative infinity symbol means an arbitrarily large negative number. So Alex says, isn't it still just negative infinity? That's correct, right? If I have an arbitrarily large negative number and I multiply it by 5, what do I end up with? Another arbitrarily large negative number, right? And that we abbreviate by negative infinity. Now, Emily, was it Emily who said our thing before? Emily, were you right?
No.
No, exactly.
Yeah.
Damn. But the reason why I asked, and the reason I was actually glad that Emily was right, not that I wanted her to get it wrong, but I wanted some student to get it wrong. It's just another way of showing you how those shortcuts that you learned aren't sufficient, right? Because I know that when I learned pre-calculus in high school, I learned the same thing. I learned that if the numerator is top heavy, we didn't use the term top heavy, but if the numerator is top heavy, then the limit is infinite. That's true, but is it positive or is it negative, right? Whether it's positive or negative actually depends a little bit more about how exactly that first term is going to cancel, and also about whether this number over here is positive or negative, right? There's more to it than that. Could we do derivatives for this? What's a derivative, Andy? No, no derivatives. We haven't done derivatives yet. The whole point of all this is to build up to derivatives. Okay. Now, there's one note I want to make here, which is very, very important, is this thing. Remember, infinity is not a number, it's a special symbol. So you always have to think about what it actually means. What if I had